Now let's look at some word problems, which is one of the toughest things in the chapter, where you're not directly given the equations, you will have to form them yourself and then solve them. There are 6 primary types of problems we'll be focusing on, which are new this year. Until last year, you have dealt with very basic linear problems like pencils and erasers, we buy these many, we buy these many. We're not going to be looking at those because those are very basic. We're going to be looking at a few new types of problems. The first type is the fraction problem. Now, in the fraction problem, we will be focusing on the concept that if I have any fraction, let's say 3 upon 5, if I add or subtract numbers from the numerator and the denominator, the fraction naturally changes. For example, if I add 1 to the numerator of 3 by 5 and subtract 1 from the denominator of the 3 by 5, we will get 4 upon 4. Or if I do something else, I add 2 to both the numerator and denominator. Numerator will become 3 plus 2, 5. Denominator will become 5 plus 2, 7. So the new fraction is 5 upon 7. So like this, fractions obviously change when you manipulate their numerator and denominator. So the problem that we have in front of us is this. We are told that when 2 is added to both the numerator and the denominator of a fraction, the fraction becomes 9 upon 11. Also, if 3 is added to the numerator and denominator instead of 2, the fraction becomes 5 upon 6. Using this information, we have been asked to find the original fraction. So let's understand how we'll approach it. Now, one key thing in linear equations or any chapter that involves variables, the first and most critical step is identifying your variables. Here, the hint is, what is the question? The original fraction. So I'm going to take my original fraction as my variables, in which I'm going to take the numerator to be x and the denominator to be y, because every fraction has a numerator and denominator. So that means my original fraction was x upon y, as we can see here. Now we apply the information. The first equation told us that upon adding 2 to the numerator and denominator, it turns into 9 upon 11, which means x plus 2 upon y plus 2 is equal to 9 upon 11. Now, if I cross multiply my fractions here, I'll end up getting 11 into x plus 2, as shown, is equal to 9 into y plus 2. Upon opening the brackets and simplifying, we come to the final equation, which we can see is done like this. Similarly, the second equation we were given was that upon adding 3 to both the numerator and denominator, it turned into 5 by 6. Once again, we can see here that I will do x plus 3 upon y plus 3 is equal to 5 upon 6. Like this, we'll cross multiply just like before and end up getting another linear equation in x and y as shown. Now, this should look very familiar to you. We have 2 linear equations, both are in x and y, and we will proceed to solve it. Now, we will solve it in whatever method we prefer, whether that's substitution, elimination, or even cross multiplication. That is completely up to you. And at the end of it, we will get our x and y value, for which we get our final answer that our original fraction will be x upon y. Here you can see the full working of the question in the way it will be done in your paper by one method that we have chosen, you are very welcome to try it by any other method. Next, we will look at an age problem. Now, it might seem familiar to you because all the way back in class 7 is the first time you deal with an age problem. However, we're going to analyze it from a class 10 perspective. Basically, what's going to happen in an age problem is that you will be given two people and you will be given some relationship between their ages. Like the following question. We are told that a father and a son have ages such that 5 years from now, the father will be 3 times as old as his son. Also, 5 years ago, the father was 7 times as old as his son. Using this information, we have to find the present ages of the father and the son. So again, let's look at how we'll formulate the equations. Like I said in the previous question, first job, identify your variables. What did the question say? Find their present ages. So I'm going to take their present ages as my variable. So we'll say, and this is just a personal choice, let the present age of the son be X and the present age of the father be Y. So currently they are X and Y years old respectively. Now let's start analyzing the situation. First equation said 5 years from now, the father will be thrice as old as his son. Now if the father is currently Y years old, 5 years from now, he will be Y plus 5 years old. If I am 25 today, 5 years from now, I'll be 25 plus 5, 30 years old. Which means 5 years from now, the son is X plus 5 and the father is Y plus 5. And what is the relationship? That 5 years from now, the father will be thrice as old as his son. Which means Y plus 5, father's age, 5 years from now, is equal to 3 times X plus 5. 3 times son's age 5 years from now. And like always, we open it up, shift around appropriately to come to a linear equation, which we can see here. Similarly, we deal with the second information that they've given us, which is 5 years ago, the father was 7 times as old as his son. So like right now we just did, the father 5 years ago will now be Y minus 5 years old. Again, if I'm 25 today, 5 years ago I was 25 minus 5, 20 years old. So the father was Y minus 5 years and the son was X minus 5 years. And again, the relationship is that 5 years ago, the father was 7 times as old as his son, which means Y minus 5, his age 5 years ago, is equal to 7 times X minus 5, his son's age 5 years ago. Again, open the brackets, shift around a little bit and get to our linear equation. Once again, we have two linear equations in X and Y. We will solve by our chosen method and get our solution. So we will eventually get the present ages of the son and the father. So another problem, once you formulate it, then it's just straightforward linear equations. Let's move on to a couple problems now which are slightly different and we'll see how we analyze them. Now we deal with what is known as a number problem or a digits problem. These questions traditionally tell you that you have a 2-digit number and then they manipulate it in certain ways. So like in this question, we are told that the sum of a 2-digit number and the number obtained by reversing its digits is 66. Also, the difference between the digits is 2. Using this, we must find the number. Now let's analyze it very carefully. What it said is the sum of the number and the number obtained by reversing its digits is 66. What this means is, imagine a situation in which your number is 25. They're saying you take 25, you take the number obtained by reversing its digits, which means 52, and adding them together. Now, of course, 25 plus 52 is 77. So obviously this is not the number we're looking for, but this is what they're talking about. Now, the way we analyze this is like this. If you think all the way back to class 5 mathematics, when you first learn the concept of place value and face value, we will use that to solve this question. Now, any 2-digit number, let us say that again, looking at our question, we know that's what we want to find. So I'm going to say, let the units digit of my 2-digit number be y and the tens digit be x. This means the value of my number is 10x plus y. Again, just take a simple example. The value of the number 18, 18, is 1 times 10 plus 8 times 1. 10 plus 8, 18. So any 2-digit number will be the value of 10 times the tens digit plus 1 times the ones digit. So in this case, 10x plus y. Now when I reverse the digits, that means y has come into the tens place and x is there in the ones place. So the value of the reversed number will be 10y plus x, like this. So the first equation we get is, we add these two. 10x plus y plus 10y plus x, number and reversed number, is equal to 66, which was given in the question. Which, quickly simplifying, becomes 11x plus 11y equal to 66, or nothing but x plus y equal to 6. This is our first equation. Our second equation says that the difference between our digits is 2. Now here you must be very careful. The difference between the digits being 2 can either mean x minus y is 2 or y minus x is 2. It does not say which digit is bigger. Now as we solve the question, you'll actually see that in both cases you just get the reversed number. If in one case I get 24, the other case I'll get 42, which makes sense because the original action we were doing was reversing the digits and solving the question. So the second equation that we take, originally let's take it as x minus y is equal to 2. Now this is actually a very straightforward question. We can very quickly do it by elimination method. X plus y is 6, x minus y is 2. I add the two equations together, the y's will get cancelled. 2x is equal to 8, which means x is equal to 4. Plug it into any of our two equations. Let's say I plug it into my first one. X plus y equal to 6. 4 plus y equal to 6. Y is equal to 2. So we get that our original number was 42. X was the tens digit, y was the twos digit. Now if we instead do it as y minus x equal to 2, once again looking at the quick elimination, we end up getting y is equal to 4 and x is equal to 2, which means our number is 24, which is just the opposite or the reverse number of our first case, which makes sense. In this way, we can solve the question. So once again, focus on your variables, focus on your equations, and of course, your basic level of maths must be strong in visualizing it in this way. But this is a common type of question, and normally it is always of this format, so you can remember it like this and approach it in this manner. Let's move on to yet another type of question. Now you'll see that they slowly get a bit more complicated. Now we'll be looking at a problem known as a rows and columns problem. What that means is, you will be told that there are students or soldiers or anything placed in rows and columns. Then they're going to move the students around to make new rows and columns, and based on that information ask you to solve the question. Let me show you an example. Let's say that we have 3 rows of students and each row has 8 students. So it will look like this: 3 rows, 8 students in each row. Now if you carefully visualize, if I move some students around, I can rearrange them into being 4 rows of 6 students each. Like so. You can see for yourself how the students are moving, and we're getting 4 rows of 6 students. I could also go the other way. I can move from 8 rows of 3 to being 2 rows of 12. Again, see the way they move from the 8 by 3 to the 2 by 12 case. And in this way, we are moving the students. This is how the question will also be formed, and they will ask you to find the original number of rows and columns. So let's say we're going to actually use a question that's based on these values only and look at what it looks like. So we're told that we have students standing in rows and columns. They tell us that if we reduce the number of students per row by 2, then the number of rows increases by 1. Also, if we increase the number of students per row by 4, then the number of rows reduce by 1. Based on this information, find, first of all, the original number of rows and columns, and of course finally the total number of students. Now there is an interesting way of solving this question and a very critical step that you will have to use. The basic logic of the question is that the total number of students is not changing. Once again, the question says find the original number of rows and columns. So we're going to say let the original number of rows be x and the original number of columns or number of students per row is y. This means the total number of students must be x into y. Fairly logical, like in our 8 by 3 case, it's 8 into 3, 24. This is what we will use to solve the question. Our total number of students is x into y. Now, in the first scenario, number of students per row reduced by 2, which means the number of students per row in this case will be y minus 2. And because of that, the number of rows increased by 1, which means the new number of rows in this case must be x plus 1. However, the number of students has not changed, which means if I multiply my rows and columns, it will be equal to xy. And you see why we do that like this. So our equation turns into x plus 1 into y minus 2 is equal to xy. As I open this bracket, I get xy minus 2x plus y minus 2 is equal to xy. And the key to see here is that xy and xy get cancelled, leaving us with a linear equation which you can manipulate however you want. I'm just going to leave it as y minus 2x minus 2 equal to 0. This is how you get your linear equation. We're going to do the same thing for the second case, where you will have, now it says the number of students per row increases by 4, which means y plus 4, because of which number of rows reduced by 1, so x minus 1. And once again, number of students is the same. So x minus 1 into y plus 4 is equal to xy. Once again, when I open the bracket, xy and xy will cancel. I will be left with a linear equation, and then, like in all the questions so far, we simply solve the linear equation. Now, as I told you, I modeled this question on our data, so your correct answer should come out to be, which we will see of course, x equal to 3, number of rows, y equal to 8, number of students per row. And so finally, when they say what is the total number of students? Well, that's just x into y as we've written. So 3 into 8, 24. So like this, you must be very careful and very clever when dealing with your variables and not panic if we see multiplication happening, because in this case especially, we just cancel out the xy. Let's move on to the final two types of problems, which are definitely the most challenging parts of this chapter.